Hi guys, so this is an introduction to imaginary numbers. So we call numbers like the square root of minus 1, square root of minus 2, square root of minus 3, square root of minus 4, and so on, imaginary numbers. So first thing anyway, up until now, you probably would have, you should realize that the square root of a minus number, it can't really exist. I mean, you're thinking of a number that times itself could be minus 25. It can't be possible because you know that when a minus number is squared, if I had minus 2 for example squared, that's minus 2 times minus 2, which is positive, because minus times minus, which is positive 4. So even when we have a minus number to be squared, it always gives us a positive number. So it doesn't really make sense that a minus number, the square root of it, could be anything. So that's why we call them the imaginary numbers. So you have to, you're going to be asked to do things with imaginary numbers. Um, right, so these rules are important then. So I equals the square root of minus 1. So I is a symbol, basically means imaginary. And then if you think about this statement, I equals square root of minus 1, then it makes sense that I squared, if you square I, that would equal minus 1. So if we were to take something like the square root of minus 25, we could break that down and we could say that's the same thing as the square root of 25 multiplied by minus 1. So I'm not really changing anything there, I'm just saying that minus 25 is 25 multiplied by minus 1. And then from that we could make a claim that the square root of 25 multiplied by the square root of minus 1 is the same thing again. So I'm just using rules of thirds here and rules of square roots. We know that the square root of 25 then, a positive 25, would be 5. And then if you look at our rule up here, I equals the square root of minus 1, that's 5 multiplied by I then, because I can put in an I instead of the square root of minus 1, so that's 5I. So 5I then is an example of how we get an imaginary number. So if we're to take another one, so the square root of minus 8, we could say that that's the same thing as the square root of 8 multiplied by minus 1, and that's the same thing as square root of 8 multiplied by square root of minus 1, and then that's the same thing as the square root of 8, and then we know that the square root of minus 1, go back to your rule up there again, is the same thing as I, so the square root of 8I. So we can call that the square root of 8I. So that's basically what imaginary numbers mean and how they can be converted. So that's imaginary number. So that's the imaginary part then of a complex number. So complex numbers then is the overall topic really. So every complex number has a real part and it has an imaginary part. So the imaginary part then will be the something I. So this is the general form then, Z equals A plus BI. So A is the real part and then B is the imaginary part. So all you got to do to remember is that the real part is the bit that's on its own, and then the imaginary part is the bit beside the I really. So let's have a look at these examples. So find the real part and the imaginary part of each of these numbers. So the bit that's on its own that isn't connected to an I in this one is the 2, and it's a positive 2. So the real part there would just be 2. So imaginary part then would be the bit that's in front of the I. So because that would be the B part. So you should be able to see here that it's going to be minus 5. So remember to put in the minus. The next one, real part would be, so the bit that's not connected to an I basically is minus 1 here. And then the imaginary part would be the 2 because it's right beside the I. The third one, it doesn't actually have any I's in it at all. But what you could do, just to make it look more like the z up here, the complex number part up here, you could put plus 0i, because 0 just means nothing anyway, so 6 plus 0i, and then it's easier to see what's the real part and what's the imaginary. So the real part then would just be positive 6. The imaginary part is nothing really, it's just 0. The last one, again, this time there's an I part in it, but there's no bit on its own, so there's no A part really. But you could say minus 2i is the same thing as 0 minus 2i. And then it helps us to see so that the real part is 0 and the imaginary part is minus 2. So that's the real and imaginary parts of each of those complex numbers. And each of these things here, they're all different complex numbers. So 2 plus 2 minus 5i, minus 1 plus 2i, 6 basically on its own, and minus 2i. So those are all complex numbers, and we've just found the real part and the imaginary part of each. So here's another question. If you want to try and find the real part and the imaginary part of each of these, just pause the video there now and then play it on, and I'll go through the answers for you. So the real part of the first one would just be 5, because that's, I mean, you could put a plus bi over each one as well, might help you to see, but you probably don't need to. The imaginary part then is just the part that's connected to the I, so that's the minus 3. Second one, real part is minus 4, and imaginary part is, see the way here there's nothing in front of the I? Okay, if there's nothing in front of the I, it's the same thing as minus 4 plus 1i. So the same way really that x is the same thing as 1x in algebra. If there's nothing in front of an I, it can't be 0, because that means that it's nothing. So it has to be 1, so x same thing as 1x, so I is the same thing as 1i. So the imaginary part here would be 1. The third one, the real part would be minus 7, and the imaginary part would be minus 2. And then the last part, similar to the one we saw before, you could say that's the same thing as 0 minus 10i. So the real part is 0 here, and the imaginary part is minus 10. So that's the real and imaginary part of each of those.